Let's now see the spectrum of a medium wave signal. You see that it is modulated, it is amplitude modulated. We can change the settings. Let me check that all is in manual, in automatic. We can change the span. With a spectrum, it is quite easy to have a stable, quite stable, but not totally, because you see that there is modulation, and so the signal, if you use a large bandwidth, is the opposite case that in FM. So now I'm taking all the amplitude modulation, and you see that the measurement is not stable because it is amplitude modulated. If I go to zero span, I see clearly the modulation. Now I am in logarithmic scale. If I go in linear scale, I can see much more modulation, sometimes till zero, but you understand that it is signal modulated. I return to the last span. So what can we do in this case with to make a good metering with an SDR? Well, we can integrate and take the PQ value, or we can do the opposite. So if we reduce the bandwidth, you remember that amplitude modulation has carrier and two-side bandwidth. In this case, we was taken all together. When I go to zero span, I was like an oscilloscope in logarithmic scale. But if I, like I can with an SDR, I go to very high resolution, you can see that modulation is on the side, and there is a point where there is no modulation, because in the modulation there is always an high pass filter. Now we are going at 50 Hertz per division, and we can look clearly the carrier, and the measurement is very stable because we are measuring only the carrier independently from the modulation. Again, we have to set differently the parameter of the spectrum analyzer if you want to take the measurement from the spectrum. Every kind of modulation needs different parameters.